Hi, today let us discuss about the module 2, that is field effect transistors. Let us discuss about the introduction part of field effect transistors and let us discuss about the N channel JFET. Okay. So what is N channel JFET? So while comparing with this field effect transistors, like BJT, it is also one important device, that is semiconductor device. Here this field effect transistor can act as a voltage amplifier as well as some of the logic switches. Then types of FETs, there are two types of field effect transistors are there. One is metal oxide semiconductor field effect transistor. In this metal oxide semiconductor field effect transistor, two types, enhancement mode and depletion mode. And the another one is junction field effect transistor. Followed by this, let us discuss about what is the difference between bipolar junction transistor as well as the field effect transistor. Okay, so the first diagram, it shows that bipolar junction transistor, and it is called as current controlled device. So why it is called as current controlled device? So it has three terminals, that is emitter, base and collector. Here the control current is called as IB, that is base current, because this BJT is called as current control device because its output characteristics are determined by the input current. Okay, so it is called as current control device. But this FET, field effect transistor, has three terminals, that is drain, source and gate. This device is called as voltage control device because output characteristics will be determined by the field in which it depends on the voltage applied, that is called as gate voltage. This gate voltage will control the entire operation of the device. So bipolar junction transistor is called as current control device and field effect transistor is called as voltage control device. So followed by this, let us discuss about the advantages of FET. So FET has the high input impedance. The next is the temperature stability. Okay, and the third is the size. It is a very compatible one and it is very smaller when compared with the bipolar junction transistor. And also if you want to fabricate this field effect transistor, we need only one or two processing. Okay. Then bipolar junction transistor is bipolar. Bipolar in the sense the conduction will happen both as holes and as well as the electron. But field effect transistor is unipolar because it uses only one type of current carrier. And the noise is very less if we use the field effect transistor. And as I told, the main application of the field effect transistor is logic switch. So followed by this, let us discuss about the types of JFET. Okay, so in the types of JFET, there is two types, N channel JFET as well as the P channel JFET. And this JFET consists of three terminals: gate, that is drain is represented by D, as well gate is represented by G, and source is represented by S. Okay, now let us discuss about the N channel JFET. So here the three diagrams are there. The first diagram is nothing but the construction of the N channel JFET, and the second diagram shows the operation, and during the operation of the voltage applied. The third diagram shows once the voltage increases, how the depletion region is changes and what are the characteristics has been changed over there. First, let us discuss about the construction of the N channel JFET. Okay, so this JFET is a three terminal device with one terminal, that is gate. Okay, that is, and this terminal is capable of controlling the current between the other two terminals, that is drain and source. And the main part of the structure is the N-type material. So this N-type material forms the channel between the P-type material. So if you see that top of the N-type channel is connected to drain and the lower of the N-type channel is connected to source. So this through the connection is happened through the ohmic contact. Okay. Then here we wanted to see that p-type materials. Okay, we used the p-type materials to form a gate terminal as well. When the p-type material is diffused in n-type, then holes and electrons will recombine. So due to this recombination, a junction is formed. Therefore, the JFET has 2 p-n junction under no bias conditions. Okay, that we can see over here. Then followed by that operation, if you want to see the operation, let us see that bias voltage is applied in the second diagram. That is, bias voltage VDD is applied, and here three basic operation conditions are there. The first operation condition, we can see that VGS is equal to 0. So at VGS is equal to 0, what is happening to the N channel JFET? Okay, here VGS is equal to 0 means the positive voltage VDD is applied over here. No, it has given applied in the second diagram. It is very clear, and followed by that the gate and source are connected to the ground. Okay, the gate and source are connected to ground, so that we can make that VGS is equal to 0 volt. Suppose the gate and source terminal are at 0 volt, the depletion region of the P material will remain unchanged. Okay, so now coming from the VGS is equal to 0, you assume that we are applying a VDS or VDS, that is voltage of drain to source. Then what will happen? The electrons will start to flow from source to the drain terminal. Okay, and whenever the electrons start to flow from source to drain terminal, the conventional current, that is drain current, the conventional current is called as drain current, that will starts to flow. Okay, so now here we need to keep it in the mind. Once the depletion region will become wide near the drain side and less wide towards the source side, because we are applying a positive voltage to the drain. No, that positive voltage will cause more reverse bias at the drain than the source. Okay, now again keep on, this VDS is increasing from 0 to 1 volt, 2 volt or 5 volt, like that. The current ID will also increase in a linear way. Okay, that we can see it in the graphical representation. See here, when VDS is keep on increasing, the current ID is also increasing linearly. So based on this, we have drawn this curve. Okay, here we have noted down saturation level, as well as here we need to think about pinch off. What do you mean by pinch off? See here, at one point of voltage, the drain current starts to begin very saturation, this constant level. That particular voltage is called as pinch off voltage. At the pinch off voltage, we marked it as IDSS. So this IDSS is nothing but maximum drain current, and this maximum drain current will be defined by the condition VGS is equal to 0 volt and VDS is greater than pinch off voltage. Okay, then followed by this, let us discuss about the second condition, that VGS is equal to 0 but VDS is increasing to some positive value. So here what we are doing, some negative bias voltage to the gate. Okay, some negative bias voltage which is applied to the gate will causes the device to get saturated. Okay, so this whenever more negative voltage is applied to the gate, this condition will causes depletion region to increase, and the device gets pinched off at the earlier stage. Now we assume that VGS is equal to minus VP. Then both the depletion region will meet and no current will flows, and making ID is equal to 0 milliamps. But in this diagram, it is very clear that the pinch off voltage, see here, the two depletion region which is nearer to the drain is very much wider, and at one point of voltage the two depletion regions has been in contact, or it has been touched each other. That particular region is called as, or particular condition is called as pinch off voltage. Then coming to the saturation region, at one particular voltage the drain current, at one particular voltage the drain current becomes constant. That is called as what? Saturation region. Okay. And the third condition, that is IDSS. Whenever VGS is equal to 0 volt and VDS is greater than VP, we will call it as IDS is equal to maximum drain current. Okay. Then the next condition, that is the N-channel JFET is, here the VDS is greater than 0 volt. So if VDS is increased to a level, that means it crosses say pinch off voltage VP, that time the depletion region will be touching each other, so that the condition is called as what? Pinch off. Then followed by this, it is called P-channel JFET. In the P-channel JFET, major structure is P-type material, and this P-type material will form the channel between the embedded N-type material to form a 2PN junction. Okay, so here current flow from source to drain. First the current flow will happen from source to drain. Therefore, the holes will be injected to source through the P-type channel and flow to the drain material. The structure and construction of the P-type JFET is, the channel is P-type and the gate is formed by N-type material. Now, whatever you have studied as the operation, just we will see water analogy method, that is a real-time example. You take ordinary water tap. Here, whenever you are opening this knob, it is turning, it is open as well as the closed. So whenever you are giving opening, the quantity, that is water, is dropping from the source and it is getting drained. So that such logic, how this water tap is working, the same logic we can apply, or we can consider it as field effect transistor. So we are calling it as voltage control device, that is gate voltage is going to be control our device. Then P-channel JFET operation. If you come to the P-channel JFET operation, only thing the materials, that is doping N-type and P-type. P-type is forming a channel and N-type is going to form a gate terminal. Remaining whatever the explanation we have done in the N-channel JFET, it is the same as for P-channel JFET. Thank you.